Okay, hopefully this video will be much shorter than the last video, but we're going to talk about domain and range. Excuse me. We've already talked about domain and range before. This is not a whole entirely new concept. We have not talked about domain and range in a little while, but also in the manner that we're going to discuss it today. What we're going to do is you're going to see things that are a little bit different than we've seen in the past. So let's just go ahead and get started. It says, remember, domain is the set of all x values. Okay, so domain is a set of all x values. Range is the set of all y values. Okay, so let's go ahead and jump in, and as long as we keep that in our head, we should be okay with this. Now, it's going to look a little different, and our representation is going to be slightly different, so make sure you watch this entire video. All right, so let's look at the first example. It says, what are the set of ordered pairs for graph number 1? So I just want us to go ahead and find the set of ordered pairs. Here I've got negative 1, 2, 3, 4, 5, 6, 7, negative 7, and then up 1. So my ordered pair for that one is negative 7, 1. I'm just going to go from left to right. So then I have negative 1, 2, 3, so negative 3, up 1, 2, 3, 4, so positive 4, so negative 3, positive 4. Then I have 0 over and 1, 2, 3, 4 down, so negative 4, so 0, negative 4. Then I have 1, 2 over, 0 up. And then I have 1, 2, 3, 4, 5. Excuse me, I went past it. 4. And let's go back here. 1, 2, 3, 4, 5, 6. I counted from the wrong spot. So I have 6 over and 1, 2, 3, 4, 5, 6, 7 down. So negative 7. All right, so what is the domain? Well, the domain is fairly simple. Don't forget your domain notation there. It's all your x values. So there's my x value, negative 7, negative 3, 0, 2, 6. And if you notice, because I went from left to right, I'm already in order from least to greatest, because that's the best way to put it in, is order from least to greatest. So I did that. Okay, I went from left to right, so that keeps me in order from least to greatest. Make sure you're trying to put this in least to greatest for domain. Okay. Range is going to be a little more difficult to do from least to greatest. I actually have to find the numbers themselves. So range from least to greatest is negative 7, negative 4, 0, 1, and 4. Again, those are all my y values. Okay, all that should have been pretty familiar and pretty easy to you. Okay, is this a function? Remember, a function is if the x value repeats. We talked about that in the first 6 weeks. If the x value repeats. So is this a function? Let's look at all of our x values. Nope, none of them repeated. Okay, sometimes we got to look beyond this domain and range because we don't always write repeating numbers in the domain and range. So we got to look up here at our original set of ordered pairs. So is it a function? Yes. Why? X values do not repeat. Okay, here's something we haven't talked about. It says this, we haven't talked about it in a while. We have talked about it. This function is called a discrete function because the graph consists of separate points. Remember, we've talked about discrete and continuous before. Discrete was another type of function where you cannot have half values. We've talked about that, and we'll get into that later. So again, this is the definition of discrete, a function because the graph consists of separate points. All right, let's look at example 2. Graph 2 is of a linear function. How do I know? Because it's making a straight line that is continuous forever in both directions. We know the line continues in both directions, so what is happening to the x values? What's happening to the y
Sylvia,
values?
if you're in the building, could you come to the front office to translate, please? We're looking for Sylvia to the front office, please.
Okay, so what's happening to my x values? And again, this is one of the ways I like to show people. So here's my x values. I go this way. Are they touching the graph? Yeah. Every single x value will touch that graph all the way down. And it'll keep going on infinitely, forever. Every single x value will touch this graph forever going up. Okay, oh, I'm sorry, I was looking at the y values. That's y values. Every single y value, excuse me, will touch the graph everywhere you go, up and down. It'll cover every single y value. Okay? Now the x value, these are my x values. Does the x value hit the graph everywhere? Yeah, and it'll continue to spread out across the bottom as it continues to go down. It'll continue to spread out across the top as it continues to go up. So every single x value is being used as well there. Okay? So we can say that the domain is all real numbers. And again, that is because as the graph goes up, the x's get bigger or smaller if it goes down, and the same thing as y. It continues on forever. So every x value will be used, every y value will be used. You can also say that the range is also all real numbers. I'm going to write it like this time. So here's our symbol for all real numbers. Okay. Okay, this graph has no breaks, so it's said to be continuous. Because again, another way to look at this is I can use fractions or decimals. Okay, it's covering every single. If it's all real numbers, you're going to have a continuous graph. All right, let's look at example 3. Graph 3 gives us part of a line or a segment. Okay, we have not talked about this year, but you should have learned this in 8th grade. This is a segment because it's not continuous. It doesn't go on forever. This doesn't go on forever. It stops right here. It doesn't even include that point because that's an open circle. And it stops right here with that point included because it's a closed circle. Excuse me. So when I start to investigate the domain or range, what I want to do is I want to find out what is the smallest and the largest x value. Okay, so the smallest x value, if I go along my x-axis, again this is x, this is y. If I go along my x-axis, I have -1, -2, -3, -4. So -4 right here is my last x value going in the negative direction, so that must be my smallest. My largest x value, I got to go in the positive direction, which would be 1, 2, 3, 4, 5. My largest x value is 5. Now, again, technically it's not 5 because 5 is not included. But for purposes of kind of creating an endpoint, well, my largest x value is 5. So again, the domain is a set of all x values. Now in this case, it's going to be the set of all x values between -4 and 5, because those are the only x values I'm using. If you look here, if I draw these two endpoints, these are the only x values I'm using right there. Okay, right in the middle. These are my only x values. So our domain is going to be written like this. Domain, I'm going to use our domain notation here. Now, again, when you see the word in between, and we use inequalities, we're going to put the x in the middle. So domain, x is greater than -4 or equal to -4, right? Because it's a solid circle. And every number here is going to get bigger than -4. So domain is -4 is less than or equal to x, but it's also less than 5, because from this point, it doesn't include 5, so that's why I don't have the equal to part. But from this point, it gets less than 5 the rest of the way. Okay, now we're going to do the same thing with the y values. What's the smallest y value? Start on the lowest y value possible. The lowest y value is 1, 2, -2. Okay, so my lowest y value is -2. My largest must be the highest y value now. And again, in this case, it's going to be +7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now again, technically it doesn't include 7 because that's an open circle, but for again a point of reference, we need to use 7. So our range is just like this because it's going to be between these points. See here, again, going this way now, I've created, all my y values are here. So I've created boundaries. So all my y values must be in between these 2 points, or these 2 lines, right? So if you have to be in between, so you're going to put your y value here. Let's make our range notation. Our y is going to be in the middle, and our signs always go the same direction. Y is going to be greater than or equal to negative 2, and less than, because it doesn't include that, just less than 7. Okay. Again, this is probably the most confusing thing about domain and range. So discrete or continuous. This is discrete or continuous. It's continuous because I can have half values. I can have fractions. Okay. And you might make that note on your paper. All right. A couple more examples, and then we'll be done. Hopefully we can go through quicker now because we understand the new way to write domain and range. Okay, again, right here what we have is called array. This is array because it's got an endpoint, and then it's got a line that goes on infinitely. So this is called array because it doesn't go, it's not a linear function because it doesn't go infinitely in both directions. It have a start point and then it goes in one direction. So we call this array. All right, so what is the smallest x value for this particular array? Okay, well look here. It's going towards the negative. So that means with this line is going to go, this point up here is going to go on infinitely. Okay, and because it's going to go on infinitely, what's going to happen is it's going to go on and on and on and on. Well, my numbers on my x value are going to continue to get smaller and smaller and smaller. So there is no smallest value for x because they just keep getting smaller. So I would put none here. What's the largest value of x? Go all the way to your right. So left is smallest, right is largest. Go all the way to your right. What is my largest value of x? Well, 1, 2, 3, 4. It's got to be stopped right here because the graph doesn't go beyond that point. So the largest value of x then is going to be 4, positive 4. So let's go ahead and do domain. So if you know that there's no smallest value of x because it goes on forever, or goes on infinitely, then our domain is going to be x must be greater than, less than, x must be less than 4. Because every number here goes to the left or goes to the negative. So all these numbers get smaller. So you have 4, 3, 2, 1, 0, negative, 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 negative forever. Okay? So every x value is less than 4 in this case. Okay, and again, it's not equal to because I have an open circle. All right, so what's the smallest y value? Again, that's your lowest point. So what's my smallest y value? Now here I do have a smallest y value. Okay, because I do end at a certain point. Well, what is that point of y? Well, 1, 2. So 2 is my smallest y value. Okay, because I do have a lowest point. But what's my largest? Can you tell where that's going to stop getting higher and higher and higher up the graph? Can you tell where that one's going to stop? No, because that arrow indicates it goes on infinitely. So there is no largest y values. It's infinite. It goes on forever. Okay, so let's do our range now. So with our range, we would say that our y value is greater than, what was this number here again? Our smallest value, 2. And again, it's not equal to because the circle's open. So our y value is greater than 2. Discrete or continuous, just like the last graph. This is continuous because it uses fractions or decimals. All right, let's look at this one. This is kind of like a quadratic. What is the smallest value for the x graph in graph number 5? Okay, so again, we're looking at our x value. This is our x-axis. So let's look for the smallest one. Well, here is the most left x point. Remember, this is a point on that part. So what number is that? 1, 2, 3, 4, 5. So that's negative 5. So our smallest x value is negative 5. What's our largest? Does it have an ending point? Yeah, here, this is a segment because here it has a beginning point and an end point. Okay, so our ending point, what's the largest? Well, we're still worried about the x. So, again, we have to be in between these points. So the x value is 1, 2, 3. So my largest x value is 3. So let's go down and do the domain. Again, every point on my x has got to be in between these two. So now I'm in between. So when I do an in-between, you got to remember, you got to put x in the middle. X is greater than what? Or equal to, in this case, because I have all closed circles. X is greater than or equal to what? What's the smallest number? Negative 5. Okay, or less than or equal to, all the x values are less than 3, right? So less than or equal to 3. Okay, let's look at our y values. What's the smallest y value? That's the lowest y value. That goes right here. So we're looking at negative 1, 2, 3. So our smallest y value is negative 3. What's our largest y value? That's the highest point. That's up here. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So our largest y value is 9. So our range, again, has to be between these two lines. So it's got to be between something. If you're between something, you put y in the middle. My lowest value first, which is negative 3. And you know all the numbers that are y are going to be greater than or equal to, okay, negative 3. So y is greater than or equal to negative 3. But they have to be less than or equal to 9. And again, remember to, not 93, 9. Remember to put it in function notation, okay? Make sure you put it in that, domain and range notation. All right, is it discrete or continuous? Again, we can use decimals, fractions, so it's continuous. All right, just a couple more examples and then we'll be done. Now this one, we're not doing the smallest and largest x values, so we did all the baby steps. Now we're just going to jump right into it. What is the domain of this graph? So now this is quadratics, which we've been dealing with lately. So let's look. Without having to write it down, what's our smallest x value? Well, what's happening here? You see the arrows up here. Okay, you see the arrows at the top. That means that's going to go on forever. And the arrows at the top of this one are going to go on forever, which means they're going to continue to spread as they go up. Okay, that's just part of the nature of a quadratic. So that means that all these x values are going to be used. And of course, these ones are being used because that's the graph. And as it spreads out, every x value is going to be used. So our domain then is going to be all real numbers. Now, 99.9999% of the time when you're dealing with a quadratic function, your domain is going to be all real numbers. If you have a quadratic function, you have forgotten how to figure out domain, and you just guess all real numbers, chances are you're going to get it right. Okay. Now, if it's not a quadratic function, and it's just a parabola that's a sideways C or a backwards C, a C or a backwards C, it's not going to be all real numbers, but then that's not a function anymore either. Okay. So these that have the parabola that opens up or a parabola that opens down is always going to be all real numbers. Okay, so let's look at range. Again, our y values. If we're looking at our y values, what's our lowest y value? Well, here we actually have a low y value. It's negative 1. Okay, what's our highest y value? Notice again, you have the arrows pointing in the upward direction that go up forever. Okay, so there is no maximum y value, so there's no endpoint. So it only has to be above this line. So that means y has to be greater than or equal to negative 1. Otherwise, my range goes on forever. Okay, my range goes on forever from that negative 1. And again, is this discrete or continuous? Okay, it can use halves, so it is continuous. All right, last two examples. Y equals x. What kind of graph is that? What kind of function is that? Well, if you look at this, this is in the same form as y equals mx plus b. Okay, because this is a singular x, that must mean it's linear. If it's linear, That means our domain is all real numbers. If it's linear, that means our range is all real numbers. Because remember, this is one of those graphs that has endpoint arrows on both endpoints that'll go on. It'll keep spreading out, okay, and going up at the same time. And so what will happen is that it'll cover every single x value, every single y value. So anytime you have a linear function, you're going to have all real numbers for domain and range. All right, last one. This one's a little more complicated. It says Jillian received a $15 gift card to download music for her MP3 player. Each song cost $1.50. Okay, so let's look at her gift card. We kind of want to. What I want to do real quick is make a quick table. So here's her x value, and we'll call her x value the money remaining on her song. On her, I'm sorry, the x value is the number of songs she purchases, and the y value is the money remaining. So songs, and then balance on her card. Well, if she buys 0 songs, she has $15, right? If she buys 1 song, she now has $13.50. If she buys 2 songs, she's going to have $12. If she buys 3 songs, she's going to have $10.50. Okay? Now I can keep carrying this table on all the way down until she runs out of money. At 10 songs, just to kind of cut to the chase, at 10 songs, she'll have 0 money left on her card. Okay, so let's think about the domain and range. Okay, what is the domain? What is my x value? Well, there's an endpoint, right? 10. After 10, it's over, right? There's no more gift cards. There's no more balance. So this is actually going to create a segment. Okay, so after 10 we stop, we're done there at 10, and we start at 0. So it's in between 2 numbers. So our domain must be x in the middle. X can be greater than or equal to 0, but less than or equal to 10. If it's at 0, she's got $15. If it's at 10, she's got no dollars. So that's our domain. Now, what's the problem with that? Okay, the problem is we can't buy half a song. So because this is not linear anymore, okay, and this is not a function, these are actually separate points. So what happens is we actually need to label out each point. So you would say domain is 0, 1, 2, 3, all the way up to 10. You cannot do this form here because then you're including halves. Well, we can't use halves. Okay, so with that being said, let's go to range. Look at your range. Again, you could say that y is greater than or equal to 15 and less than or equal to 0, but the problem is you cannot have half a song. You can't have half a song, therefore you can't pay 75 cents for that half a song. So then our range is going to have to be these values listed. So you would have 15, 13.5, 12, so on, so on, so on, all the way till you get down to 0, and you'd have to list each point. This is one of those scenarios you have to list each point. So then the last thing is this: is it discrete or continuous? Well, it's discrete because you have individual points. Now you can use fractions here, but you cannot use anything other than 0.5 and a whole number. So you can't use every fraction. So it is discrete. Okay. All right, so make sure you watch the video all the way through, take notes, bring it in tomorrow, and we'll work on it when you come in tomorrow.